Hey, if you're joining me, that means you're being an advocate for yourself, and that is amazing. So let's have a quick review of the things we've covered so far in Unit 5. Now we're up to 5-9, which is great, right? We're trucking through Unit 5, but we still have a lot of learning left to go, and I know if we work together, it will be amazing. So let's start. 5 friends each have W number of apples. So there's 5 of them, they each have W number. Their teacher gives them 3 more. Draw a model, write an expression, and evaluate for W equals 6. So what I'm drawing right now is how my mind is imagining this. 5 people, they each have W, and then there's this plus 3. But if I want to make a really awesome model that looks a little bit better than my little scratch notes over here, I can make this look like a bar and then cut it into some pieces. So I'm going to double check. I have 1, 2, 3, 4, 5 little squares, and I'm going to label them W. Why? Because I have 5 friends and they each have W number of apples. In that final square rectangle that I have, I'm going to put 3 dots. Why? Because I have 3 that were added. Now to write an expression, I could do multiple things. I could say 5W plus 3. I could do W plus W plus W plus W plus W plus 3. I could do, 2W plus 3W plus 3. Either way, all of those are expressions, and I'm going to be able to evaluate it for W equals 6. And I'm feeling soups fancy because I wrote more than one. Yay for me. So I picked my 5W plus 3. Remember, the 3 that I wrote, they're all equivalent. I plug in the number 6 for W. So 5 multiplied by 6 is 30, plus 3 is 33. I'm feeling pretty good about that. Now, there's 33 apples. I made sure to label it. I feel better when I can label that. So I have 5 multiplied by the difference of E and 3. I could also say that I could say 5 multiplied by E minus 5 multiplied by 3. I could say that too. Either way, I'm imagining this in my head different ways. And when I'm able to write them out like with words, so 5 multiplied by the difference of E and 3, I'm a powerful mathematician. So I rewrite it because I'm going to be using the distributive property to evaluate. Now, when I use the distributive property, we have to remember what we can give, we can take away. In this case, we're going to give 5 to distribute to the E and 5 to the 3. So 5 multiplied by E and 5 multiplied by 3, I get 5E minus 15 as a final answer. That's using the distributive property. Now, I can take away, and that's when I would find the greatest common factor and evaluate that way. So that also works. Or I could write it as 5 sets of E minus 3. Any of those work. Now why? Because they are equivalent expressions. And it's cool to see different ways of how it would be written. I know, pretty cool, right? I kind of messed up in the middle, but that's okay. And when I'm writing, I keep trying to count, like, okay, how many E's have I written? 1, 2, 3, 4. Either way, I'm thinking yowza, and I'm proud of myself. Let's go to the next page. Chad, Dan, and Tyler have W baseball cards each. One day, they put all their cards together and lost 4 cards. Draw a model, write an expression, and evaluate for W equals 12. So there's Chad, Dan, and Tyler. They each have W baseball cards. So I put the W's on it. So one day they put all their cards together. They're like, hey, let's put all the cards together. And they lost 4 cards. Hashtag sad. And I know that when they lose 4 cards, I'm probably going to be thinking subtraction. So that's where my mind's going. Let's start with a model. Probably for the best. I'm thinking I'm going to draw a really long rectangle total, so I could split that up into tiny little rectangles. Now within these rectangles, I'm going to write W, and I'm going to draw some dots. Now these dots, I have 4 big ones and then some little ones. Why? Because I don't know what the W actually represents. It could be anything. So I have some dots drawn in there. I also did this because I'm going to be subtracting it. If I was adding it, you've seen me in the past not add those dots at the bottom, but because I'm subtracting, I'm going to do it that way. So I have my 3 friends. They have some dots in there, and I'm actually going to take another color in there, and I'm going to strike out 4 of the dots. Now why? Because they lost 4 cards. How irresponsible of Chad, Dan, and Tyler. But that's okay, we forgive them because we can still use them for this math problem. So I write this as an expression, 3w minus 4. I can also say w plus w plus w minus 4. Either way, it's going to work. So I plug in 12 for w. 3 multiplied by 12 minus 4. 3 multiplied by 12 is 36, minus 4 is 32. Time for the next page. We are going to describe a situation, make a diagram, and write 2 equivalent expressions to the following expression. 8w plus 3. Now you notice I do w a lot. That just happens to be my favorite letter. So let's write the situation first. Now this is where I get to be creative. So there's 8 of something, so 8 students. And they have, what would students have? You know what, they have W SOAR tickets each. I don't know how many they have, but they have W SOAR tickets each. Their teacher, they must be amazing, right? So they earned 3 more SOAR tickets from their amazing teacher. Maybe her name's Ms. Billman. I don't know. I mean, I'll just throw that one out there. So how many do they have total? Now, I added that sentence at the end just to help draw my mind to, that's kind of my end game, finding the total. Now I need to make a diagram. For my diagram, I'm going to draw another rectangle, and I'm going to split it into 8. And there's 1, 2, 3, 4, 5, 6, 7, 8, and then I have a little one left over. And I always number them to double check. I don't want to go through and have my diagram be wrong. That would be super sad. So each of them get W labeled inside it. There's 8, they get W, and then 3 added on to the back. So if I wanted to write an equivalent expression, I can use my model to help me. I could write W plus 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 3. I could write 4w plus 4w plus 3. I could write 2 multiplied by 4w plus 3. I mean, I have some options here, and it's good to have options. And when I'm recognizing that there are multiple expressions, I'm taking it to that next level of noticing and acknowledging the equivalent ones. I'm being a powerful mathematician on a mission, and I'm glad you're here to join me. Let's take it back to the order of operations. Now, I'm not necessarily going to start with the 22 because I know that there is an order. So the end isn't the best place to find an answer. Parentheses is where to go, right? Me and my friends at our table doing math. Working faster and we talk slow. And exponents up next in the order of ops. Now remember, with multiplication and division that comes next, we go left to right. The same as with addition and subtraction. So exponents up next in the order of ops, and trust me, give it a chance. We're going to start with that 2 to the second power. Remember, 2 to the second power is not 2 subtract 2, it's 2 multiplied by 2, which is 4. And I rewrite the expression each time. 22 divided by 11 plus 6 minus 4. Now I can go to the division. 22 divided by 11 is 2 plus 6 minus 4. I'm going to work left to right. Because they're both addition and subtraction, I work left to right. So 2 plus 6 is 8 minus 4, and that'll give me a final answer of 4. Yes, good job, self. I'm feeling powerful right now. And it's always a good refresher to go back to the order of operations. Now this time I have an expression that has 2 variables, x and y, and we're going to plug in a certain number for those variables. So variables stand for something, and now they've given me a number. So y squared multiplied by the sum of x plus 2 minus 5. So I plug it in. 3 squared multiplied by 4 plus 2 minus 5. I do the order of operations, and the end isn't the best place to find an answer. Parentheses. Parentheses is where to go. So I start with my parentheses. 4 plus 2 is 6. And I rewrite the expression each time. 3 squared multiplied by 6 minus 5. Check my parentheses off. Exponents, I have that. 3 squared is not 3 multiplied by 2, it's 3 multiplied by 3. And that's 9. Now time to multiply. 9 multiplied by 6 is 54 minus 5. Time to subtract. I get an answer of 49. Now I'm putting all these things that I've learned together. It actually is kind of fun. So we're going to combine like terms. Now I noticed in the middle here, that's like saying 3 groups of 2b. And I can use the distributive property to evaluate that and kind of pull it out. So I distribute the 3 to the 2b and I get 6b. So 4 plus 6b plus 6. Now I can't combine the 4, 6b, and the 6, but I can combine the 4 and the 6, and that's equals 10. And it's 10 plus 6b. There aren't anything, aren't any other terms in there that I can combine. Now you notice these are same and they're similar, so we're going to be combining like terms, but they do look different. This one has the difference of 9 and 4 squared plus m plus 2c plus 3m plus c. So the difference of 9 and 4 is 5, and we square that, so 5 squared plus m plus 2c plus 3m plus c. Whew. I've got to do my exponents. That's 5 multiplied by 5, which is 25. And I'm rewriting it each time so I can understand my thinking. I'm going to grab another color, and I'm going to start circling things that I know I can put together. The m and the m can go together. So 1m plus 3m is equal to 4m. So 25 plus 4m. I'm going to grab another color because I know I can combine the c. So 2c plus c is equal to 3c. So 25 plus 4m plus 3c. It started out pretty long, and we actually evaluated it to be quite small, which feels good. So let's write 2 equivalent expressions for each of these. So 4c plus 2. Now I could do c plus c plus c plus c plus 2. That works. I could also do, well, I could do 2c plus 2c plus 2. I could do that as well. And I could even use the distributive property on that one. Let's look at 3 multiplied by the sum of 3b and 2. Distributive property, 3 multiplied by 3b is 9b plus 6. Or, and I'm going to try to use an uppercase b. My lowercase b ends up looking like a 6. Or, what I could do is I could do 3b plus 2 plus 3b plus 2 plus 3b plus 2. Because that original expression is like saying 3 sets of 3b plus 2. And they're all equivalent expressions, which feels pretty good. So 5d minus d. I could have d plus d plus d plus d plus d minus d. Or you can be really creative and do 4d. And that's it, simplified. Now 6r plus 2s, I'm going to try the distributive property. I'm looking for the greatest common factor between 2 and 6, and it is 2. I pull that 2 out. And I know 2 multiplied by 3 is 6, and then 2 multiplied by s will be 2s. So I can still get the same answer of 6r plus 2s. Or I could write r plus r plus r plus r plus r plus r plus s plus s. Whew, that was a mouthful, but I made it through, and I'm feeling super fancy and super extra for using the distributive property.